All right, let's talk about the magic behind tools like ChatGPT. It's called the Transformer, and it completely changed how AI works. But we're not going to get bogged down in a bunch of code. Instead, I'm going to break it all down with a simple story.
I mean, have you ever stopped to think about it? How an AI really understands you. Not just the words, but the nuance. The difference between I saw a bat, the animal, and I need a baseball bat. It honestly feels like magic, right? Well, it's not, but it's close. You see, the answer is this absolutely revolutionary idea. And the best way to get our heads around it is to forget the math and just dive into a story. So let's imagine we're visiting a very special, kind of magical translation office.
Welcome to the office. Our job today seems pretty simple. We need to translate the sentence, "The cat sat on the mat." But it's how this office works that is just so incredibly cool.
Okay, first things first. Before any work gets done, our words need to be converted into a language the office can understand, and that language is numbers. This whole process is called creating embeddings. The easiest way to think about this is that every word gets a super sophisticated ID badge. So the word cat gets a badge with a specific pattern of numbers, and dog, it gets a badge with a really similar pattern, because they're both animals. But the word jump, its badge is going to look totally different because it's an action. It's a clever way of encoding meaning into math.
All right, so every word has its ID badge. Great. But we've got a problem. In our magical office, there's no queue, no single file line. Everyone works at the same time in one big room. So how do we know the order of the words? I mean, dog bites man is a very, very different story from man bites dog.
The solution is this brilliant little trick called positional encoding. You can think of it like adding a special, invisible stamp to each ID badge. The stamp tells the office not just what the word means, but exactly where it is in the sentence.
And it's way more clever than just numbering them 1, 2, 3. It's more like giving each position its own unique musical note. So words that are right next to each other have very similar notes, while words that are far apart sound totally different. This gives the whole system this rich, intuitive sense of the sentence's structure.
Okay, so our words have their meaning, and they know their position. Now we get to the part that is truly revolutionary. It's time for the all-hands-attention meeting. This is the secret sauce. So picture this. In this meeting, every single word gets to look at every other word in the sentence. Let's just follow the word sat. Sat basically stands up and asks, okay, I'm in action, but who's doing me and where am I happening? Immediately, other words raise their hands. Cat shouts, hey, I'm the one doing the action, and Matt says, and it's all happening on me. So Sat instantly knows that cat is super important to its meaning, and Matt is also really relevant. Not so much. So sat then absorbs the meaning from the most important words around it.
And just like that, boom, the word sat is no longer just a verb floating in space. It now has a new, context-rich identity. I'm the action, performed by a cat, happening on a mat. And you have to remember, this incredible update happens for every single word, all at the exact same time. It's amazing. But wait, it gets even cooler. The model doesn't just hold one of these meetings, it runs several at the same time. This is called multi-head attention. It's kind of like having a whole team of specialists looking at the sentence. One head might be an expert on grammar, another on who's next to who, and a third on figuring out what a pronoun like it refers to. Then they combine all their findings.
So after these frantic meetings, every word is buzzing with all this new contextual information. But we're not done yet. Now it's time to process it all. Time for a little deep thinking.
So each word takes its new, richer self into a private thinking room, just to sort of process everything it's learned. In the real world, this room is called a feed-forward network, but all it really is a quiet space for each word to consolidate its new, updated meaning. Now, with all this updating, there is a tiny risk. A word could get so focused on its new context that it forgets what it originally meant. But the designers built in this brilliant little safeguard called a residual connection. After each step of updating, the system essentially taps the word on the shoulder and says, hey, here's your original ID badge back. Don't forget who you are. It's a simple trick that makes sure the model never loses the plot.
And here's the thing. This whole process we just walked through, the attention meeting, the thinking room, that little residual reminder, that's just one layer. Transformers stack these layers, sometimes hundreds of them. It's kind of like drafting an essay. The first layer gets the basic grammar down. A few layers later, it understands semantic roles. By layer 12, it's grasping abstract, nuanced ideas, ready for a perfect translation.
Okay, let's zoom out. For a big job like translation, our magical office is split into two main departments. You've got the encoder department and the decoder department.
Think of it like this. The encoder's job is to understand. It reads the entire original sentence, say in English, and uses all those layers we talked about to build this super rich, deep understanding of what it means. Then, the decoder's job is to generate. It writes the new sentence word by word. And for every single word it writes, it constantly looks back at the encoder's complete understanding to make sure it's staying true to the original meaning.
So that's how the office works. But the big question is, why was this so revolutionary? What was it about this idea that completely upended the entire field of AI?
Well, the old way of doing things was basically a game of telephone. Models would process words one at a time, so information from the very first word had to be passed down the line, getting a little weaker and more garbled with each step. The transformer? It's a conference call. Every word talks directly to every other word at the exact same moment. No middlemen, no information gets lost. It's a total game change.
And this conference call approach had three huge benefits. 1. Speed. Because everything happens at once, you can throw massive computer power at it and train these models way faster. 2. Memory. The first word in a giant book can have a direct line to the last word. This was a massive problem for older models. And 3, we can actually peek inside and see which words are paying attention to which helps us understand how the AI is thinking.
This core idea has spawned a whole family of different models. You've got models like BERT, which are basically just the encoder part. They are fantastic at understanding text. Then you have models like GPT, the G in ChatGPT, which are just the decoder part, perfect for generating text. And then you have models that use both, for tasks that need to transform an input into an output, like translation or summarization. So, look, the next time you're at a party and someone asks how ChatGPT works, you can just tell them this. Imagine every word in a sentence gets on a big conference call. They all talk to each other at once to figure out the real context. That big meeting? That's the secret. That's why it gets you.
And that really brings us to a final mind-bending thought. This whole revolution was built on letting words have a universal conference call. But now that we're applying that same idea to images, to sounds, even to DNA, it really makes you wonder, doesn't it? What incredible new conversations is AI about to start?